Hello, Honor Algebra. It's Mr. Lawrence here, and we are going to do a little interruption video here. We'll do some practice with factoring, so we got to make sure we're good on it. We're going to go into something new, but we've got to pick up some pieces, make sure we're not going too fast. Today we're going to learn how to name equations by the number of terms and by their powers, and we're also going to talk about the commutative property and associative properties. All right, so let's get right down to it. There's two ways to name polynomials. The first way is by their degree. Okay, the first way is by their degree. And if something is to the first degree, oh, by the way, how do we know where the degree is? The degree, like 32 degrees, the degree is up here, right? The degree symbol? Well, we count by the highest power, the highest exponent. So for example, this is a fifth degree term. Okay, why? Because the exponent's 5. This polynomial is still fifth degree because the highest one is a 5. Okay, you go name it by the highest term. If I had this would be seventh degree. Okay, because the highest exponent is 7. All right. So a first degree polynomial, something like looks like this, 5x plus 1. That is called a linear polynomial. That is said to be linear. And we will study more about that later, but if you pay attention, you can see the word line is hiding in there. Now I know somebody's thinking, hey, Mr. Lawrence, I see the word ear. Yes, but we don't use a lot of ears in math. Um, and there's a big joke in there for teachers, but anyway, I'm going to let that one ride on out of town. All right, so a first degree polynomial is said to be linear. A second degree polynomial, like perhaps we have to do x squared minus 5, or better yet, a 3x squared plus 2x plus 1. That is said to be quadratic. These are quadratic. And let me write this down in here. This is quad. I don't have enough room to write. Hold on a second. This is said to be quadratic. Okay, if its highest power is 2, it's quadratic, okay? Later on, we're going to learn something called the quadratic formula. You've heard me talk about x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. That's the quadratic formula. We'll have to learn that later. All right, here we go. Third degree. I'll bet you can think of third degree like, if you had 4x cubed, okay? Or maybe, let's see, 5x cubed minus 2. Okay, those are said to be cubic. Yeah, that's a cubic. Okay, now the fourth degree ones, fourth degree is when the highest power is 4. Oh, wait a second. There we go. We'll move those down just a little bit. All right. So if I have something like, say, let's see, fourth degree, how about an x to the fourth minus 2? Okay, the highest power is 4, right? That would be quartic. That's a weird term, but that's what it's called, a quartic polynomial. All right, now there's also a way to name them. You're going to need to learn those. You might want to make flashcards and memorize them or something like that. But there's a way to do the number of terms to name it. Okay, if there's one term with no variable, like a 7, that is simply called a constant. And you've heard me use that a lot. It's constant because it doesn't vary. There's no variable. It doesn't change. If there's one term with a variable, for example, like an x or a 7x, okay, those are called monomials. Mono meaning one. Monomials, okay? Let me see here. Let me move this stuff down a little bit, give myself some room to work. Okay. If you have two terms, okay, and it doesn't matter to what degree those terms are. For example, you might have 3x plus 1. There's two terms there. Okay, it doesn't matter that one's a constant. You might have 7x to the fourth plus 2x squared. There's two terms there. Those are called binomials, bi meaning two. Like bicycle, it's a two-wheel cycle. Okay, so binomials. Okay, if you have three terms, that's an easy one. Say like x squared plus 4x minus 1. That is a trinomial. And again, they don't have to, the powers don't matter on the terms. Like this is also a trinomial. If I have, 10x to the 17 minus 2x to the ninth plus 3x, because there's 1, 2, 3 terms. The terms change at the addition or subtraction signs, or positives or negatives, however you want to think about it. Now, when you get 4 or more terms, it's simply called a polynomial, or that's what happens when you forget to feed your parrot. Poly meaning many, okay? More than 3 is considered many, so that is many terms. So we can name, and we should name, each expression by both degree and by the number of terms. So let me see here. Let me give myself a little bit more room. And let me move this guy down and this guy down. Okay, first I'm going to check the degree. Looks like on this one I have a 2 for my degree. So this is quadratic. Okay, this is quadratic. Oop, not dratic, dradic. It's a D, quadratic. And there are 2 terms, so that makes it a binomial. So this is a quadratic binomial. Okay, this one here has a 4th degree, which makes it quartic. And there are 3 terms, so it's a quartic trinomial. Right? Okay, this one here is to the 7th degree, and I don't think I talked about that. You simply say it's a 7th degree. There's one term, monomial. Yeah, 7th degree monomial. All right, this one here, the highest power is 1, so that makes it linear. And there are 2 terms, which makes it a binomial. So it is a linear binomial. Okay, hold on one sec. Okay, you go ahead and try to name these 4 problems and pause the video, and when you're ready, go ahead. All right, here come my answers. The degree is 3, so this is a cubic. There's 2 terms. It's a cubic binomial. Okay. Number 2, highest power is 2. It's a quadratic. Ah, I spelled quadratic wrong. I'm going crazy here. It's been a long day. Quadratic. Yeah, it is quadratic. I'm sorry. I told you earlier that it was quadratic, and it's actually quadratic. Silly Mr. Lawrence. I'm sorry about that, ladies and gentlemen. Okay, quadratic, trinomial. Okay, it's a quadratic trinomial. 3 terms. 1, 2, 3. This is a 4th degree, so that means it's quartic, and it's a quartic monomial. Yeah, there's only 1 term right there. Okay, and this one is not a polynomial. It's actually degree 0, which we wouldn't mention, right? It'd be like x to the 0 power. Okay, so we don't do the degree. And it's just one number without a variable. This is just called a constant. This is just called a constant. You don't need to put this in here. That's just to show you it's like the 0 degree. Okay, we don't have a name for 0 degree other than 0 degree that I'm aware of. All right, how are we doing on time? We're doing okay. All right, some of you asked some questions about the commutative property and the associative property. The commutative property allows me to say that 5 plus 3 is the same as 3 plus 5. It means commute, it means to go back and forth. It also allows, that's the commutative property of addition. It also allows me to say that 3 times 7 is the same as 7 times 3. Notice the order changes. The commutative property order changes. That's the key to identifying the commutative property. All right, the associative property. This is where the grouping changes. The grouping changes, right? Okay, so for the grouping, if I have 3 plus the quantity of 4 plus 5, that would be the same as the quantity of 3 plus 4 plus 5. Notice the 3, 4, and 5 are in the same positions. However, I've grouped the 4 and 5 together. Here I've grouped the 3 and 4 together. Now, if you don't believe me they're the same, this would be 3 plus 9, following the order of operations, which is 12, right? Well, this would be 7 plus 5, following the order of operations, which is 12. So you see they are indeed the same problem. This is the associative property of addition. Of course, it applies the same way for multiplication. If I have 2 times the quantity of 4 times 3, that's the same as the quantity of 2 times 4 times 3. Well, let's use zero operations. We can get 12 times 2, 24, right? And here, we're going to get 8 times 3, which is 24. And you see they are, in fact, the same. So this is the associative property of multiplication. Okay, so you might want to review that. Here, what I'm going to do, I'm going to give you some problems, and you're going to have to tell me which property it is. So give me a second to get that set up. Okay, so I've got set up with a couple problems here. So hopefully you're reviewing those properties. Again, if you want to make flashcards of them, you go right ahead. I would like you to take a moment and try to identify which property is commutative or associative, and if it applies to addition or multiplication, which will be super duper easy. All right, go ahead and pause the video when you're ready. Unpause the video and you can see my solutions. Okay, problem number one, here comes my solution. Well, let's see. I see a 6, a 4, and a 3. And then I see a 6, 3, and 4. It doesn't matter there's parentheses in the problem. I'm asking myself, did the order change or did the grouping change? If the order changed, it's commutative. If the grouping changed, it's associative. Okay, so in the group I have 4 times 3. Here in the group I have 3 times 4. So the grouping did not change. The order of the grouping changed. So the order changes, that means it must be the commutative property. It's involving multiplication, so it's a commutative property of multiplication. And I'm using that little asterisk or star or whatever you want to call it. Okay, problem number two. I see parentheses. It does not make it associative automatically. I see, did the grouping change? I have 2 plus 3. No, because I have 2 plus 3 there. Here I have a 5 in front of the group, and here I have a group in front of the 5. Looks like the order changed on this one. This would also be the commutative property, and this would be of addition. See, I hope you're not just going, oh, there's parentheses, so therefore it's associative. No, that would be an elementary idea, and that would be incorrect. It doesn't apply to what we're doing. Okay, 8 times 7 equals 7 times 8. There is no grouping. Did the order change? It sure did. So that is also the commutative property. And this is the commutative property of multiplication. All right. This one here, I have grouped one. I have the numbers 1, 9, and 4. 1 and 9 are grouped. Here I have the numbers 1, 9, and 4 in the same order, but the 9 and 4 are grouped together. That would be the associative property because the grouping changed. The grouping is not the same. I have different numbers in the group. Okay, number 5 is a little bit tricky. Two things have changed. Look, I've got, uh, no, actually only one thing has changed. Oh, it's changed twice. I've got the group in front of the 3, and then I've got the 3 in front of the group. So that is the commutative property. The only thing is, inside the quantity, the order changed again, didn't it? I had 1 times 2, now I have 2 times 1. This is actually the commutative property being used twice. I could convert it, say 1 times 2 times 3 is the same as, let me see, 3 times the quantity of 1 times 2. And I can say that because of the commutative property, right, of multiplication. Let me slide that down here. Okay, but that's not the same as what the black line says. So now I could take this new answer, this 3 times, or I could take this answer and then adjust it 3 times the quantity of 2 times 1. And now this looks like that. And that I can do again because of the commutative property. Okay, now you might be thinking, is it always the commutative property? I kept showing all the same answers. Well, no, I was afraid that if you saw parentheses, you would automatically go, oh, it's got to be associative. It's not automatically associative. You have to ask yourself, did the grouping change or did the order change? If the order changed, it's commutative. If the grouping changed, there are different numbers in the group, then it's associative. All right, that's the video for tonight. Have a good night, everybody.